Hello and welcome to which I believe is the last video for chapter 16 if you're in the class. And this kind of puts a lot of the stuff together and it reviews on something that we did earlier. So if this is a problem you could follow me, okay, you could follow me through and you could kind of do, then you're doing really well, okay? And this is actually a lot of fun. So here's the random variables. Julie's 50-yard swim times. Okay, and you have Mike's 50-yard swim times. Okay, that's up and back in a pool if you don't know. That's up and back. Okay, if it's not the Olympic size. Okay, uh, that's the small one when they turn the pool the smaller way, not the long way. Okay, so what happens every time she swims, it's going to be a random event because you don't know what her times are going to be. So this is actually continuous random variables, so not discrete. Okay, so we're under a curve, and both of these curves are normal, which which means this. I could draw a normal curve for Mike's times. I could draw a normal curve for Mike's times. So if I did normal, well, what is he expected to get? He's expected to get Mike 25.98. And what's his standard deviation? 3.76. Okay, so this is my mu of x, and this is my standard deviation of x. Same notation as here. Okay, so I'll just put the means here. 25.98. That's his average swim time. Remember, the smaller the number, the faster they are, the more they win. Okay, and I could model Julie's over here. Right here is a normal. Okay, so this is also normal. It's always good to draw the picture. Think, show, tell. So I'm thinking about the problem. I'm showing. Okay, and she swims in 27.88 seconds. And she's a little more consistent, 2.1. So she's a little bit more consistent. Okay, so I could put this. And I'm gonna ask a pretty simple question. And on average, who's gonna win more? Okay, and by how much? So on average, he comes in at 25.98. On average, that's 27.88. So more often than not, Mike's going to win. So let's go ahead and find E of MST JST. Okay, so let's find this. The expected value of Mike's swim time minus Julie's swim time. Okay, so this is just the expected value of Mike's swim time minus the expected value of Julie's swim time. Which Mike's swim time was 25.98 minus Julie's swim time was 27.88. Okay, so what's that going to be? Negative 2.10. I will verify just so I don't mess up. How did I mess up there? 25. Okay, see? 25 to 26. That's right. That's right. Negative 1.9. Negative 1.9. It's not 2 seconds because it wouldn't be that. It's not, yeah, you see. I see it. Okay, so think about what this means for a second. Pause the video and try to think about what that means in context of this problem. Then I'll come back to it. MST minus JST. Okay, so we have to find the variance first. So I square this. I don't need that 2 there. Okay, so this is going to be the variance of MST minus JST. Okay, which equals the variance of MST plus the variance of JST. And I'll say it one more time. If I have variance here, there's variance here. There's error. If there wasn't any error, it would just be one single time. He'd have to get the same time every time for there to be no variance. So there's variance here, and there's variance here. If I subtract these two, okay, I'm not going to get less variance. You're going to get more variance. That's why you add them. You add. Okay, so what's this? So what I need to do is find the variance of MST. The variance of MST is 3.76 squared, okay, plus the variance of JST. The variance JST is 2.1 squared. Okay, so let's add those together. 3.76 squared plus 2.1 squared equals, okay, I'm going to need that in a second. So that's going to be 18.5476. Okay, so that's the variance, but I don't want the variance. You want the standard deviation. So the standard deviation of MST minus JST equals the square root of the variance of MST minus JST, which you just found to be the square root of 18.5476. You should get used to writing these notations and being very complete. It just makes you look like you know what you're doing. But if you're using the notation, you do know what you're doing. So I did the square root. I put this number in here, doing second answer, and it's going to be 4.306. Okay, so that's my mean, and that's my standard deviation. So now let's look. What did you think this meant in context to this problem? Okay, this means on average, Mike will beat Julie by 1.9 seconds. Okay? Does that necessarily mean that Julie will never beat Mike? Okay? Define this question. Do you think Julie will never beat Mike? No, Julie will beat Mike, because think about it. If Mike swims at 25, but his standard deviation is 3.76, okay? So if Mike goes this way, this is a good day, right? He gets faster. But standard deviation is up here, 3.76. This over here would be Mike's bad day. Okay? So what happens if Mike has a bad day? Do you think it's out of the ordinary for him to swim at 28? No, it's not out of the ordinary for him to swim at 28, because think his standard deviation is almost 4. Okay, so he's swimming like a 26, 27, 8, 29. It's not out of the ordinary for him to swim at 29. So if he has a bad day and she's on average, she's going to beat him. Okay, so she won't beat him more often, but she will beat him. Okay, so now I need to come up with a new distribution to answer this third question. Okay, so to answer the third question, I need a new distribution. I need the distribution of the differences. I just found them. I just found it. That's a new mean, and that's a new standard deviation of the differences of these two distributions. Okay, so this is going to be a review. So the expected value of, okay, so some people like to call this something else, like the difference, but the expected value of Matt's swim time minus Julie's swim time was negative 1.9. And the standard deviation of Matt's swim time minus Julie's swim time equals 4.306. This number could never be negative. And think about it. This was normal, and this was normal. So the new one's going to be normal. The differences. I need to graph the differences. These differences. So here it is right here. I'll do it real big, just normal. And what's going to sit in the middle? The expected value, which is negative 1.9. Okay? Because I'm trying to find the probability that Julie beats Matt. Was it Matt or Mike? Julie beats Mike. So what happens here is this is all the way. Like for example, here Mike wins. Okay, so let's see. If I go to the left, it's more negative. So I'm just going to move to the left. -2, -3, -4. So what's a negative number mean in terms of who wins and who loses? So right here, that negative 1.9. Who won? Mike won, right? When does Julie win? Okay, look at MST minus JST. Okay, MST minus JST. So if this is small and this is large, okay, this equals a negative number. And who won? Smaller number, Mike would win. Okay, so let's look at the other way. Julie wins when her number is smaller than Mike's. Okay, so Julie wins when her number is smaller. So look at, when this is small and Mike is large, Julie wins, right? Smaller number wins. It's a swim, it's a race. Okay, so this would yield a positive number. Positive number. What if they tie? MST minus JST. What happens if it's a tie? So this is the same and this is the same. You would get same number minus same number would be 0. Okay, so where's 0 on this number line? If that's negative 1.9, 0 is somewhere over here. This is 0 right here. So any number over here is a positive number. Any number over here is a negative number. So we know negative numbers. The negative numbers, Mike wins. The positive numbers, Julie wins. Well, I'm trying to find out the probability that Julie beats Mike. So that would happen in this shaded part. Okay, in this shaded part right here. So this is a normal distribution. The mean is negative 1.9 and the standard deviation is 4.306. Okay, so do you remember how to find the area to the left of, or to the right of 0? Find this area. It's very important. You can't forget. So this is a good review on something we've already done. So what we have to do is we need to convert this 0 to a z-score. Convert that 0 to a z-score. So I need to standardize these values. Okay. So this negative 1.9 turns into a 0. I'm looking for this value right here. I'm looking for this. And the way you do that, it's z equals the number that we have, that we're looking for, 0 minus a negative 1.9, 0 minus a negative 1.9 divided by 4.306. So a negative and negative is a positive, so 1.9 divided by 4.306. Okay, so that's my so this number here is 0.44124. So I want to remember, now that I have that, I just have to do normal CDF. Okay, put in my start, which is 0.44124, and then put in a large number. And this will give me this area here, which is this area here, which is the probability that Julie wins. So just a refresher, that will be second distribution. Second distribution, normal CDF is number 2 down there. Okay, so I have this number just above it, so I'm going to save it into there, comma, pick a big number. enter. So Julie will win about 33% of the time. So go through this example, okay? Because it's very important. And when I say it's very important, you're going to see it again. You have to be really comfortable with doing this, okay? So thanks for watching.